Hello, I'm Associate Professor Ben Holken and I'm in the Vibration Lab at UTS Tech Lab at Botany. And I wanted to do a quick video just to show everybody our automatic modal impact hammer, which can be found in cabinet 2 on the modal hammer shelf in the Vibration Lab at Botany. So I'm just going to take the hammer out of the poly case here and show everybody what's inside the box. Okay, so inside the box we've got some documentation with respect to what the hammer is. There are two types of hammer. We've got the SAM1, the small one, some other information. There's a manual. We've just had the hammer upgraded in May 2023, so there's a user manual and instruction manual here which I recommend people to have a look at before they attempt to use it as well, obviously having looked at this video. Also in the box are the items that are included since we had the system upgraded: the hammer itself, dongles and software installations, calibration documentation. We don't have this one at the moment, but we do have these holders elsewhere in the Vibration Lab, and then some cabling and some other items, and a couple of pictures showing all of the contents of the box with the automatic hammer. These are the old documents from prior to having the system upgraded. We keep those also for reference. We have a power cable, standard kettle lead as it's referred to as, a USB cable which provides the communication between the modal hammer and the computer system. I just noticed that the modal hammer wasn't immediately there. There's a power supply also which provides power for the stepper motor, which is what drives the automatic hammer. Here we have the Pro box with the dongle in it, which needs to be connected to the PC on which we're running the software. There'll be a second video showing how to use the software. The software installation is on here, but it shouldn't be the case that for computers that are available in the Vibration Lab, we need to do a software install. They should all be installed already. There's also some beeswax in here for mounting other accelerometers, also for potentially making the mass of the impact hammer heavier to get more force into the structure. So this one lives in here, and then there's also a laser pointer, which you might reasonably wonder why the laser pointer is included as well. This can be connected to the acquisition system PC, and then we can use the left and right keys in fact to drive the hammer backwards and forwards when we're setting the 0 position, but I'll describe that in more detail in the subsequent video. The hammer itself is in a very nice stainless steel casing now since we had it upgraded. Here is our signal out, which is for the force transducer. This needs to go into our acquisition system. Here's the USB power. I showed previously the USB cable. So this just connects to standard USB on a computer, and this is the micro USB cable. Provides the communication between the stepper motor controller, which is inside, and the software within the PC. And then the power for the stepper motor itself coming from this this external power adapter is connected here. There's also a trigger input BNC connector here if we wanted to provide an input trigger signal to be able to tell the hammer when to do an impact. And when all of the cables have been connected, we can then power on the hammer and it will be ready for use. On the top side are a couple of M4 screws by 1mm pitch, and they are, I believe, approximately 10mm deep. So we can mount, for example, this to a plate like I showed on the paperwork, which we have elsewhere in the lab. I'm going to forget about that screw for the moment. Alternatively, if we look inside the box a little bit further, underneath this first piece of foam, there is a height gauge, and this height gauge is possible to be used to mount our hammer. So we can remove these two screws. There are two screws here. We can mount the hammer to this bracket, and then we can use this combination of screws to change the height of the hammer. We can put it into a position, and then we can mount our structure underneath it, and once it's ready to go, we can excite the structure with automatic impacts. It's important that we set the 0 position up such that when we have a structure, and I'll show this in a subsequent video when I'm demonstrating how to use it, such that the hammer is impacting the structure normally. We need not to be exciting the structure at an angle like this. This isn't good practice. We would need to be exciting the structure normally, always, to get proper excitation in the direction normal to the surface of the structure. And we can set that up in the software. As I say, I'll demonstrate that in a subsequent video. One more thing to say about this hammer is that there is a connection, a cable connection inside of here between the force transducer, which constitutes the hammer, and the acquisition system. This cable is of finite length inside. It means that we can't continue to rotate and rotate the shaft many times, otherwise the cable will get wound up inside and will eventually fail, and we've done that previously twice. Soon we will be having a modification to this device sent from the manufacturer to prevent overwinding. It essentially will be a mechanical stop, but in the meantime please pay attention to these labels on the side asking you not to overturn or overwind the hammer shaft. The hammer shaft is very delicate. It's in an ABS 3D printed material. It's intentionally flexible. It's meant to essentially whip the surface like a drumstick, right, to excite the structure and put energy into the structure. And we measure the response of the structure with either laser vibrometers or other types of contacting transducers. Please take great care with the hammer itself. It's deliberately flexible, but it's also very delicate. Previously, we damaged one. It failed across the clamp mount to the shaft. Probably it was a design flaw. They've changed the shaft now to include a flat on here such that the hammer itself can't rotate on the shaft, but we still do need to take care with this entire structure, especially when putting it back into the foam box, because it's quite easy to catch the hammer shaft when placing it back into the foam box. Okay, so that's an introduction to what's in the box for the modal impact hammer, and there'll be a follow-up video showing how to use it in software in the future. Thank you.